Okay, guys, starting to chapter 3.1, quadratic functions and models. So to start off the chapter, in general, we're going to talk about polynomial functions, okay? 3.1 specifically will focus on quadratics, which are polynomial functions, just probably the most simple ones to deal with. So a polynomial function f of degree n, where n is a non-negative integer, is given by f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus all the way down to a sub 1 x plus a sub 0, where a sub n through a sub 0 are complex numbers with a sub n not equal to 0. Okay. Now that may look, a little confusing, but the thing to realize here, sorry, I'm just trying to get this guy straightened around. The thing to realize here is that these are just numbers, okay? So I'll give you a few examples of what these look like. So for example, here's the function f of x equals 3. Technically, that is a polynomial function of degree 0. The degree is just the highest power that our variable is raised to. Here I don't have a variable, therefore the degree is 0. The leading coefficient here is just the number 3, okay? Now, when we look at this next one here, 2/3 x minus 1, this is a polynomial function of degree 1, because I technically have an x to the 1 here. And the leading coefficient is 2/3. So the leading coefficient is just the coefficient in front of the variable raised to the highest degree, okay? So if I look here, f of x equals 3x squared minus 4. Degree is 2, leading coefficient is 3. And finally, if I have f of x equals x to the 4th minus square root of 2x plus 5, this is of degree 4, and its leading coefficient is 1. Okay, because we have an assumed 1 in front right here. Okay, so that's our polynomial functions in general. And specifically for 3.1, I want to talk about quadratic functions. Now, quadratic functions are of degree 2. So for example, this one we looked at up here. Okay. And let's define that. A function f is a quadratic function if f of x equals ax squared plus bx plus c. So basically, it's the same thing as a polynomial, just with these three terms, where a, b, and c are complex numbers, and a is not equal to 0. Now, with these quadratic functions, with the polynomial functions, I know we are saying complex numbers. 9 times out of 10, we're talking strictly real numbers, okay? So we might see 1 or 2 that have complex numbers as their coefficients, but generally, we don't deal with those, okay? So the simplest quadratic function is probably f of x equals x squared, which we all know what that looks like, right? So let's see what we can get a little more in general here. Quadratic functions in general can be written in this form right here. F of x equals a times x minus h squared plus k, okay? Now, what you'll probably recognize is this should remind you of transformations that we did back in the last chapter, okay? So right here, we like this form because it tells us a few things. It says that we take the graph of x squared and we shift right by h units, right? That's what we would do normally in our transformations. We'll shift up by k, okay? So that just goes along with what we learned in the last chapter. And we'll stretch vertically by a factor of a, okay? And that's just going along with our transformations. Now, when we look at this in general, it may look, let's say, maybe something like this, okay? So I want to get just a little bit of terminology here, okay? Right here, the lowest point, or it could be the highest point if our shape was like this, if I had something like negative x squared. This lowest point right here is called the vertex, and it occurs at the point hk. So this is the vertex of the parabola. And the line that goes right through the center here is always at x equal to h. This is called our axis of symmetry. Okay, so we're going to want to know what these things are. Okay. So in general, the graph of the quadratic function f of x equals a times x minus h, quantity squared plus k, is a parabola with vertex hk, axis of symmetry x equals h. If a is positive, it opens upward. If a is negative, it will open down. Okay. So let's look at a simple example right here. Okay, this is in that nice form. So if we're looking at this, and actually let's, I'm gonna tweak it a little bit. I'm gonna throw a negative out front here. So here's what I want you to notice when we compare it to here. Notice that the value of A is -1, if we compare it to this form up here. What that tells me is this is going to open down, okay? And I also notice that I have H and K here, okay? H and K, if I compare, is going to be -4 and -1. So that tells me my vertex, -4 and -1. -4, -1. And I know it is opening downwards from our A value. Okay, so we're looking at this right here. And we also know that we have an axis of symmetry right here at x equal to -4. Now the axis of symmetry tells us that if we take this and we flip it over, it'll land on itself. Okay. So that does it for our first video for 3.1.